Friends, today we are going to design a 12 volt power supply. This is the schematic diagram we are going to use to build our 12 volt power supply. We can start by presenting the components. We have the transformer and we have the transformer here. After the transformer we have semiconductor rectifier diodes. Then we have semiconductor rectifier diodes. They are 1, 2, 3, 4 connected in a bridge. So 1, 2, 3, 4. We'll connect them in a bridge. Then after that we have an inductor. So this is an inductor. Then after an inductor we'll have a capacitor. After a capacitor, then after capacitor we'll have a voltage regulator, IC 7812. In addition to that, we will require a power source, which is here, the main AC source. We'll require a breadboard, which will allow us to mount all these components. Then we'll require a digital multimeter for measurement purposes. Let's now understand the schematic diagram. So you can see that the single phase power which we are receiving from the source is 240 volt. So what we want to achieve at the output is a 12 volt DC. So this is a 240 volt AC. So this 240 volt, we need to step it down to a manageable level whereby we'll be able to handle it, okay? And which will provide to us 12 volts. So for us to be able to step down that voltage, we need a transformer. So that is why a step down transformer is placed here. So this step down transformer is going to take the 240 volt to a manageable level of voltage. This is how AC signal looks like. AC signal change direction, okay? It change the polarity. At times, one time is positive, at another time it's negative, okay? So the AC signal keep on changing. So we're going to rectify this AC signal to DC signal. So this is how a DC signal looks like. So a DC signal does not change the polarity, or it does not change its polarity. Now for us to be able to remove this AC from this way, this signal to be to have DC output, we need to pass it into different stages. Stage number 1 is the bridge rectifier. So the bridge rectifier, its work is to rectify the AC signal into DC. So we have to feed this AC signal into this bridge rectifier. After the bridge rectifier, we'll no longer have AC, but we'll have the DC. So this is how the output of bridge rectifier will look like. Let's take this signal. When this side is positive, okay, this side is positive, so this will come, step down the transformer and come, it will pass to this diode. This diode is forward bias, okay? This diode will conduct and allow that current to pass through, and it will continue to the system. So then it will return to this diode back to the transformer, and the process will continue. This side, now this becomes negative, this becomes positive. The same way will happen, the current will come, okay, it will pass through this diode and it will continue through the system, and when it returns from here and return back to the system. So this bridge rectifier, this will keep the positive voltage on one side, and it will keep the negative voltage on the other side. So after rectification, this is what we are going to achieve. We'll no longer have positives and negatives, but we'll have a continuous output like this, okay? So this is the continuous output we'll have. This is now a DC. Now what we want to achieve is this one. So we need to pass this voltage to another stage so that we will continue until we reach this signal, DC signal. After rectification, guys, we need to pass it to filtering circuit. So today we are going to use LC filter. LC filter means inductor and a capacitor. So this is an inductor and this is a capacitor. So you're going to use these two components to remove the AC component from the rectified DC. Remember that when you rectify the AC signal, we will get DC, but we'll still have some components of AC signal inside that voltage. So we need to get rid of those components. So we'll have to connect LC filter. First of all, we'll connect an inductor after an inductor, and we'll connect a capacitor. This is how it works. The rectified voltage will come to the inductor. The inductor offer very high reactance to AC signal, but low into DC signal. So when this DC will be coming, reaching here, all the AC components which have been in that DC will be blocked by this inductor. So the inductor will block all those AC components, and it only allow DC to pass through. So when they are blocked, the AC is blocked, the DC will pass through. Then things made by human beings are never perfect. So there will still some other components of AC which will be passing through, okay, because human beings always make mistakes. So all the AC components which escaped from the inductor will be shorted by the capacitor. So the capacitor will filter all those remaining AC components. So this type of filtering is more efficient compared to capacitor filter. This is because the AC signal is going to go through two stages. Stage number one, it will pass through the inductor. The inductor will block all the AC components and only allow DC to pass through. Then secondly, all the components which has escaped from the inductor will be shorted down by the capacitor. Then at that, we'll have an output which looks like this. So after the filtering out, we'll be having an output which looks like this from the filter. So you can see we are getting closer to the DC component. So after filtering, then we'll have to pass this voltage through the last stage, which is known as voltage regulation stage. Okay, so in this project we are going to use 7812 because we want to achieve 12 volt at the output. So this voltage which is coming from the filtering circuit, it is a DC, but it's not stable. It will keep on fluctuating due to the nature of the input voltage. So for us, what we need a constant DC output. So for us to be able to achieve such voltage, we need to pass it through a regulation stage. The regulation stage will give us a smooth and neat DC output regardless of the type of the input power. So we're going to feed this voltage from the filter circuit to the voltage regulator. Voltage regulator has 3 pins, okay, as you can see. Pin 1, pin 2, pin 3. So that's what I've drawn here. Pin 1, pin 2, pin 3. So pin 1 is where you connect the incoming voltage, the incoming voltage, the voltage you want to regulate. So like here, this is pin 1. Then pin 2, you connect the ground. You can see I've shorted here to the ground. Then pin 3 is where you will get your output to. It's where you will get your output. So you can see pin 3 is going out and provide us 12 volt. So guys, this is the circuit diagram of our project. Transformer gives power to bridge rectifier to filter after filtering, voltage regulator after voltage regulator. Now we'll have a DC power. After this, at this point now we'll have to test this power by connecting a load.